Microfluidics is a new technology that allows you to test samples and do research using tiny amounts of liquid. Here at the University of Southampton, we make microfluidic chips by mixing a treacle-like fluid, called PDMS, with another liquid that helps the chip set. When the mixture is stirred, small air bubbles form. These would interfere with the workings of the chip, so they have to be sucked out using a vacuum. This metal disc is called a large wafer array and is used like a jelly mould to shape the channels of the microfluidic chip according to the needs of the finished product.
At this point, the PDMS mixture is added to the mould and is heated to allow it to set. Here is the completed chip with the pattern of channels clearly visible. As the chip is less than a quarter of the size of a £5 note, just imagine how small the channels are.
The footage of the people on the left represents the random movement of fluids. On the right-hand side, this much more ordered motion demonstrates the control you have over liquids, using microfluidics.
The tiny blobs of oil in this slowed down lab footage can each enclose a single platelet, which is a cell smaller than dust that helps blood to clot. Microfluidic technology enables us to minimise the scale of our research and study each cell individually.
In the near future, a microfluidic chip could be used to test blood in a GP clinic. With the results available in the same appointment, the patient would be saved days of worry that come with waiting to find out your results. Many different diseases, drugs, nutritional deficiencies could be tested for using a single drop of blood on a single chip. Imagine current lab research as working with a pen and paper. Microfluidic technology will allow researchers to perform multiple reactions using tiny volumes of liquid. Saving both money and time, this advancement in lab processes is comparable to the leap to these supercomputers.
Microfluidics also has the potential to massively reduce the number of animals tested on for medical research. Using microfluidics, only a few cells from a mouse are required, and the equivalent of 10,000 experiments can be carried out per mouse, rather than just a couple. As a result, far fewer mice will have to suffer.
In 2010, 95 million people were tested for HIV and AIDS across 119 countries. Just imagine how many more at-risk patients could be tested all across the world using this extremely affordable technology. This is just the first chapter in the story of microfluidics, but the future is looking bright for the rest of the story to be written.